8M4, linear equations in two variables. Let's hit it. Okay, let's hit our screen share and go over to our lesson. So the first thing I want to talk about, this we'll get to this bottom piece in a second, but let's talk about what are linear equations. How can you recognize a linear equation in two variables? Well, I'll tell you, the key is this. You'll have lots of equations that are written like these below. And you can just look at them and stare at them, and it's not maybe obvious to you which are linear equations and which are not. We're going to cover these examples in a second. But the key is a linear equation in two variables will always have, it will either have, in some cases, one or two variables. It will almost always have two variables. Sometimes these linear equations will have one variable, and I'll show you that in a second. But B, each occurrence of a variable will have an exponent of one, you know, the number 1. And remember, if I write an equation like this, 2x equals 10, this x has an exponent of what? Of 1, right? Any variable, a variable without an explicitly written exponent has an exponent of 1. Right, so this is really the same thing as saying 2x to the first power equals 10. These are equivalent. But we as mathematicians like to keep things simple, and so we have this special rule that if the exponent is 1, we simply don't write it. So this has an exponent of 1. So let's look at these examples down here, and let's see which ones follow the two rules and which ones then are indeed linear equations in two variables. Okay, so let's look at this first one. Does it have one or two variables? Yes, it has it has two variables. That's true. Each occurrence of a variable will have an exponent of 1. Well, that has an exponent of 1 because it's not written, and that one does too. So these are both like, this is like 2x to the first and 4y to the first. So those are both exponents of 1. And so that is, yes, this is a linear equation. I know, in other words, if I draw this on a graph, it will be a straight line. It will be a linear equation. Linear equation, this means line. So if I draw it on a graph, it will be a straight line. So I know that before I even graph 2x plus 4y equals 12, when I put that on a graph, it better be a straight line. It's not going to be some curve. It's not going to be a circle. It's not going to be a parabola, crazy word parabola. It's going to be a straight line. Let's look at this one. Well, I have two variables, and each one has an exponent of, 1. So even though this is a subtraction sign, this is also, doesn't matter if your variables are added or subtracted, this one has all the right criteria. So this one too These are both linear equations. Now let's look at this one. Well, in this one I have my y on one side and my x on the other side. Well, there's nothing in the rule that says that that's not okay. So I have two variables and both have exponents of 1. So this too, this is a linear equation. So we have all linear equations. Now let's look at this fourth one. Well, we have x and y, two variables, so we're okay on the first front. But the problem here is that the second one has a exponent of 2. So this is not a linear equation. Now, how about 5? Well, this is that special case. We can sometimes have just one variable. So we're okay here on 5. But do we have an exponent of 1 for our variable? Yes, we do. Okay, so this is also a linear equation. Now let's try number 6. This is clearly, I mean, if you're listening or paying any attention at all, you'll see these variables or these exponents right here. And so this is not a linear equation because we have exponents that are 2s. So that's not a linear equation. How about 7? Well, we have two variables, exponents of 1. Do we worry about these fractions? No, we don't. We don't care what the coefficients are. There's no rule about coefficients here. So this is indeed also a linear equation. So now we kind of hopefully got the hang of this. We should know that if we graph 1, 2, 3, 5, and 7, we should, when graphing, I'm going to write this out. When graphing linear equations, we always get a straight line. What happened there? Whoops. A straight line. Line linear. That's where we get the word linear. Okay, let's move forward and let's actually do some of this. Let's work with these linear equations and start to understand them a little bit better. Okay, so let's go here. Now, what you're going to do in this lesson, and you probably did in class all day, was you had a linear equation given to you. And how do we know this is linear? We got two variables and the exponents are both 1. And you found 5 solutions and then you plotted them. So we're going to go about that exercise right now. Okay, so let's recall what a solution to an equation is. A solution are values that make this equation true. So let's see, would I have a solution if I said, let's try some numbers. So if I said a solution to this equation, let's try x being 4 and y being 3. So x equals 4 and y equals 3. Now that's a possible solution. Now is it a solution? Well, we have to plug the number in and see if it makes it true. So if I have x equals 4, I'd take my x and I'd put a 4 in for x. And I'd take my 3 and I'd put that in for y. And I'm going to see if that's true. Is 4 plus 6 equal 10? Yes. So this is a solution. So this is yes. Now let's try another number. Let's try like 5 and 3. So let's try x equals 5 and y equals 3. So this is a solution. So if I put a 5 in, let's go 5 plus 2 times 3 equal, does that equal 10? Well, does 5 plus 6 equal 10? Well, that's no. So this is not a solution. Okay, so let's talk about how we find solutions to linear equations. Well, here's one way that we can do it. We'll do it in this color, purple. We're going to make a chart here. And we're going to try values for x and y. Now, let me tell you that the easier thing to do is, okay, so I'm going to try some values for y. Let's do it this way, and then I'll tell you why I did it this way. So we're going to put our y here, and then we're going to do this equation, and then we're going to figure out what x has to be to make this thing true. So let's say y is 0. Let's start with a nice, easy number like 0. So now I'm going to do some math, and I'm going to say, well, if y is 0, I'm going to say, well, here, I'm going to put my x here. And I'm going to say, well, x plus 2 times 0. So we're trying y equals 0. X plus 2 times 0 equals 10. So x plus 0 equals 10. So x equals 10. So when y is 0, x is 10. Okay, now let's try y equals 1. So if y is 1, then x plus 2 times 1 equals 10. So x plus 2 equals 10. So x equals 8. Now let's try y equals 2. X plus 2 times 2 equals 10. X plus 4 equals 10. So x equals 6. So when y is 2, x is 6. So hopefully we're getting the hang of this. So now y equals 3, we get x plus 2 times 3 equals 10. And if you do the math, you get x equals 4. And now we're going to try y equals 4. And you get, if you try this one, x plus 2 times 4 equals 10, you get x equals 2. And so now what we have is 5 solutions. Now, one thing you do when you write a solution, when writing solution, we often write in coordinate form. Coordinate form or ordered pairs. Sometimes we usually call them ordered pairs. And ordered pairs or ordered pairs. Okay. In ordered pairs, you always say x comma y. You always put your x value first. So if we were going to write this as these solutions here is ordered pairs, we would say x comma y. So we'd say 10 comma 0. Why 10? Because that's our x coordinate. This goes first. So we go 8 comma 1, 6 comma 2, 4 comma 3, and 2 comma 4. Okay, so now we actually have let's see, we got to erase. Uh-oh, where did our graph paper go? Uh-oh. Oh, you know what? We don't want to fill, do we? Let's see here. Okay, forget this. Let's go. Okay, so but we're still gonna try and graph. Let's still graph these guys. So I got to figure out how to put graph paper back on this thing. Not sure how to do it after I'm erasing it. I thought I'd get my graph paper back, but there's something happened with this new version of Sketchpad where things are a little goofy. Okay, sorry about that, but I think you'll still get the right idea. So we're going to make our graph. Oops. We need to make our graph, our line. Our line, let's see, our outline has to be a little fatter than that. Let's go fatter. And let's go with the color that's purple. There we go. Okay, so we're gonna make our graph here, and we're gonna make it 0, 1, 2. I'm gonna try and line things up nicely on this. On this weird kind of graph paper here. Whoops. 1, 2, 3, 4, 5. Maybe I'll get some nice background. I'll find some nice background paper. Okay, so let's plot our points. We have 10, 0. Uh-oh, I didn't make this line perfectly straight. I can see this already. 10, 0, 8, 1, 6, 2, 4, 3, and 2, 4. And that's nice. So you can see, and now we can make our line. So this should make a straight line. I made my graph a little bit wonky, but let's make this in yellow. And you can see we have a nice straight line through all of our points. And so that's how we create our 5 solutions, and then we make our graph. And again, I apologize for this. I'm going to try and figure out how to do this graph paper a little bit better. Okay, let's do another example. So in this example, we're going to use some different numbers. Let's use these numbers. So this is kind of, at this point, we're kind of in homework help mode because we're going to do the same thing over and over. And this is really all this lesson's about is finding 5 solutions and then graphing. 5 solutions and then graphing. So let's do this problem this time, and let's go. 2x. No, let's do this one. Let's go 5 halves x minus y equals 6. Okay, so in this case, what we want to do, let me show you something. Do we want to find 5? So we either, when we're creating these solutions, when we're creating solutions, let's make some steps. When creating solutions, start with 5 values of x or 5 values of y. then solve for the other 5 values. Okay, that's A. And I can tell you, hint B is almost always, it's better to choose the values for the variable with the fraction. Okay, that's not always true, but it's almost always true. So here, are we going to start with 5 values for x or 5 values for y? Well, the rule says let's start with values for x. So let's put x here, and then we're going to solve, and then we're going to find some, write 5 values here for x, and then we're going to solve for values of y. And now, why is that? And the reason is that let's just see what happens. If I start with values for x, let's try a 0 for x, and let's see what happens. So I go, I'm telling you this is going to be the easier one. So we go 5 halves of 0 minus y equals 6. Right? We know our x is 0. We need to find our y. So here we get 0 minus y equals 6. So we get minus y equals 6. And then we get y equals -6. So that's kind of nice. Now, what would happen if we started with values of y? So we said, okay, well, let's make 0 be our value for y. So we're going to put a 0 here for y, and we're going to find out what x is. So now we have 5 halves of x minus 0 equals 6. And then we get, 5 halves of x equals 6. And now we have to find out, now we're going to have to multiply both sides by 2/5. And we get, that cancels, nice. And now we get x equals 12/5. So here we have, we end with a fraction. We have harder math because we're doing this cross canceling. So this is why we like to start with values for that variable with the fraction. Now, if that doesn't make sense, you can just memorize the rule. But I tried to give you a little bit of intuition about why it's better to choose variables or values for variables that have the fractional coefficient. So let's try some other numbers here for x. Now, if I'm choosing numbers for, one other key thing is when I'm choosing these numbers for x, do I want to choose even numbers or odd numbers? Do I want to choose, am I going to choose numbers like 1 and 3 and 6 and 5, or would I rather choose even numbers, and why? Well, let's look at this. I'm going to tell you that it's better to choose numbers that are going to cancel with this 2. So let's watch what happens if I choose an odd number. So what if I chose the number 3? Well, here, if I chose the number 3, I'd get 5 halves of 3 minus y equals 6. And here I end up with, okay, well, that's 15 over 2. I have a fraction. And the last thing I want to do is be working with fractions. So I don't want to do this. So I want to choose numbers that when I plug them in for x, they're going to create a cancel situation. So I'm going to choose 2, 4, 6, and 8. So let's watch what happens when I do each one of these. 5 halves of 2 minus y equals 6. So this is when x equals 2. So that cancels. So I get 5 minus y equals 6. Minus y equals 1, because I'm subtracting 5 from both sides. So y equals -1. So now let's try x equals 4. 5 halves x minus y equals 6 Well, that's 5 halves of 4. 5 halves times 4 minus y equals 6. Cancel, cancel, 2. 10 minus y equals 6. So that's y equals 4. 4 comma 4. Oh, that's neat. Now when x equals 6, I get 5 halves of 6 minus y equals 6. Cancel, cancel, 3. 15 minus y equals 6. Y equals 9. Now let's try x equals 8. 5 halves of 8 minus y equals 6. Cancel, cancel. 4. 20 minus y equals 6. Y equals 14. So there's my ordered pairs. Let's write them as ordered pairs now. We go x comma y, alphabetical order. 0 comma minus 6. 2 comma minus 1. 4 comma 4. 6 comma 9, and 8 comma 14. Okay, we are cooking with gas. Let's get going. 0, negative 6. So I have to go from 0 to 8 on my x-axis. So let's, and then negative 6 to 14 on my y-axis. So my x-axis is kind of all in the positive. But my y-axis is y. So my x-axis, I got to go from 0 to 8. So let's see. So I can go 0, 1, 2, 3, 4, 5. Remember, I got to start at 0 and keep even intervals. But for my y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, let's take it all the way up into here. I'm going to label it in a different color so that we can see it a little better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is 15 right here. 1, 2, 3, 4, 5, minus 5, 1, 2, minus 10. Okay. So 0 comma negative 6 is right here. 2 comma negative 1 is right here. 4 comma 4 is right here. 6 comma 9 is right here. And remember, it's got to be a straight line. If I don't end up with a straight line, I did something wrong. 8 comma 14 is right here. And now I go about making my line, which goes through all of my points. Something I'm, oh, right, you can see it. I'm off by 1 because I plotted my point wrong. So we'll fix that in a second. Right, this is 8, this is 14. 14 is right here, not there. And there you have it. This is how we graph solutions to our linear equations. Now, there's sometimes you're going to get, and this is kind of a bonus. Let's just do it though. Let's do it. You're going to get these questions that look like this, and these turn out to be linear equations, and these are very common linear equations, and these are actually used in business and by businessmen and women when they're doing calculations to try and maximize what they can buy. So let me just write this. Let me write out the simplified version for a student, but these things can apply to things that you would buy in real business as well. So let's see. You can buy a drink for $1. So you're at the store. You can buy a big bag of chips for $3. So you're buying, so you're at the store, right? You're at the store and you're buying stuff for a party, and you have, $27 to buy stuff for a party. What options do you have if you want to spend all the money? Okay. And it turns out that the problems written like this are linear equations. And we won't go into exactly why right now, but let's just look at this. So what can I do? I can buy a drink. We're going to call it drinks D, and we'll call the chips C. So let's see. I could buy, what if I bought all drinks? I could buy 27 of them, right? I could buy 27 drinks, and that would be $27, and then I could buy no chips. What if I wanted to buy all chips, nothing but chips? Well, I could buy 9 bags of chips, and I could get no drinks. Well, what if I wanted to buy a little bit of each? Well, if I bought no chips, I could buy 0. If I bought all chips, I could buy 9. So what if I bought 4 bags of chips? So let's see. So chips would have 4 chips. That would be 4 times 3 equals 12. That's our chips. Then we'd have $15 left over. And so we could buy 15 drinks. All right, so if you want to do the math on that, that would be $15 in drinks, and that would be $12 in chips, and that makes our $27. So what about another number? What if we bought 6 bags of chips? Well, 6 bags of chips would cost us 6 times 3, that's $18, and we'd have $9 left over, and so that would let us buy 9 drinks. All right, what if we just bought just 1 bag of chips? Well, that would be, and you can choose whatever you want. You could have chosen different numbers. I just chose these numbers. So if I buy 1 bag of chips, that's $3, and then I could get 24 drinks. So let's now graph this, and let's make sure that this is indeed a linear equation. And chips, we're going to put chips on the y-axis. Here, let's see if we can fit 27 of them here. Okay, so we're going to do this in blue. See, this is 0, and we're going to call this 0. Let's go back and make these blue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And so these are our chips. No, these are this will be our drinks. So our drinks is on our x-axis. So this is our x and this is our y. Right? So our chips, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is 10. 1, 2, 3, 4. Okay, so we can buy 27 and 0, 27 drinks and 0 chips, or we could buy 0 drinks and 9 chips, right? That's 27, 0. And this is 0, 9. And this is 15, 4. This is 9, 6. This is 24, 1. So let's look at 15, 4, 9, 6, and 24, 1. And now let's make our line. Uh-oh, we graphed something wrong, but we'll fix that. Figure out what exactly we did wrong there. Because this is, see, I put the point in the wrong place. And after you draw the line, you see that you made a mistake. I didn't graph 15, 4 right. 15, 4 should have been right here, right on the line. And I didn't draw my line right. So let's just go back and let's fix this. 15, 4. This is 27, and this is 24, 1. And this is 9, 6. And there you have it. So there are a few examples like this. You know what? And let's lay down our happy cat here. Because this is kind of a tricky one. And what makes it tricky, what often makes these things tricky, is that they are word problems. And just know that whenever you have these word problems where you have a certain amount of money and you can buy a certain amount of one thing and a certain amount of another thing, that ends up being a linear equation. Okay, well, I think that's enough for today. And let's end this as we always do, with a little clap. And we will see you next time with 8M4 lesson 13.